Hey everybody, in this video I'm going to explain how to name a special class of substances called acids. First, let's talk about how to identify acids by recapping another type of substance called covalent. Covalent substances, as you may or may not know, are composed of only non-metallic atoms. So if you had a periodic table and remembered that everything to the right of that staircase shown in red, so here it's all the atoms highlighted in yellow, those are all the non-metals on the periodic table. That would tell you that substances like CO2, made of carbon and oxygen, both non-metals, meaning CO2 would count as a covalent substance, just like H3PO4 and P2O5, all only made of non-metals. That's important because acids are a type of covalent substance. So acids will also be made of non-metals, almost exclusively. You'll see a few exceptions where a metal is thrown in there, but primarily non-metals. What really makes an acid in most cases is that they will contain the element hydrogen. And you can usually spot it in the formula of an acid because that hydrogen is typically written at the beginning. So a substance with a formula like HCl, because you're spotting that hydrogen at the beginning, that's cluing you into the fact that this is an acid. Sometimes there's 2 or even 3 H's, like in H2CO3, and again in HNO2. These make up some of the key ideas for this video, so make sure to pause and take some time to write that down. Now let's get into the actual naming of the acid molecules themselves. Acids are named according to the type of negative ion, which we call an anion, that the hydrogen is attached to. So that means if we've got our 3 acid formulas, we're really going to ignore the hydrogen altogether and focus exclusively on the thing that the hydrogen is attached to. So in these 3 examples, the chlorine, the CO3, and the NO2, that's what's going to tell us how to name each acid. There's 3 guidelines. If the ion's name, shown in red, ends in IDE, and typically that's for monatomic ions, so single atom ions, you're going to name the acid using this format, hydro blank ic acid. If the ion that the hydrogen is attached to ends in 8, which you'll see for polyatomic ions, you're going to name the acid with this format. So I'm going to bring up a list of polyatomic ions in the top right at this point so we can use that. But we'll get to the last rule first. If the ion ends in ite, I-T-E, that's also going to be with polyatomics, then you're going to name the acid using this format. Knowing all that, let's go through these 3 examples of acids and how to name them. So remember, we're just going to focus on the anion that the hydrogen is attached to. And in this case, it is a single atom, or what we would call a monatomic ion. And ions like this, if you were to name it, remember you drop the typical ending of chlorine, and you would just call this chloride. Well, that name, and more particularly the fact that it ends in IDE, tells you how to name the acid, because when the ion ends in ide, you're going to use this template of hydro blank ic acid. So that's how you select which acid name to use. The last part of the puzzle is that blank spot, which is often called a root word. The root word comes from the ion name itself. Because Cl is called chloride, it has the root word chlor. So we will sort of plug in chlor into that blank spot to come up with the official acid name of hydrochloric acid. Let's do another one with H2CO3. We're going to ignore the hydrogens and focus just on the ion that the hydrogens are attached to. In this case, it is CO3. That is a polyatomic ion, and if you find it on a polyatomic ion list, you can look up what its name is. In this case, CO3 is called carbonate. The important part is that it ends in 8. And when the ion ends in 8, we're looking at this middle rule, so we're going to use this format for naming an acid, blank ic acid. Your job then is to plug in the root word from the ion name, and for carbonate, that root word is simply carbon, making this carbonic acid. For our last example, we'll do HNO2, ignore the hydrogens, focus just on the NO2. This is again a polyatomic ion, so we'll come up to my polyatomic ion list, find NO2, there it is, and we can see that it is called nitrite. The important part is that it ends in ite. And because it ends in ite, we're going to use the final template for naming an acid, blank, O-U-S, acid. That blank, again, is the root word from the ion name NITR to get a final acid name of nitrous acid. So that's how you do it. That's how you name acids. You want to make sure to jot down those 3 naming rules. We've got one final thing to mention here, and that is with some acids, there's a special guideline to pay attention to when you're naming acids involving sulfur or phosphorus. You're going to keep the UR and the OR in the name of the acid from that root word, and the UR and the OR would typically be dropped off, but for acids, you're going to keep them in there. Let me show you exactly what I'm talking about with 2 final examples. If you had the name H2SO4, you would look up SO4 on your polyatomic ion list and see that it's called sulfate. Since it ends in ate, you'll name the acid using this format, ic acid. And if you just took the root word as it seems it would be in the name of sulfate, you would be plugging in SULF to get sulfic acid. That might even sound a little strange to you because with sulfur, you're going to keep in the UR. So even though the raw root word as it is in sulfate is just SULF, we're going to keep the UR in there to officially call this sulfuric acid. So that UR is going to remain for any acid involving sulfur. And the same pattern exists with phosphorus-containing acids. PO3 is called phosphite. Since it ends in ite, we're going to use this format for our acid name, OUS acid. The raw root word is just phos, PHOSPH, but we're not going to just use that. We're going to keep the OR in there since it is a phosphorus-containing acid to get phosphorus acid. And that's how you name acids. That also wraps it up for this video. Thanks a lot for watching, and here's a brief summary.